Moving on to Geometry Lesson 11.3a, we'll be working with similarity in triangles, but within right triangles. Theorem 11.3.1. Right triangles have several unique characteristics. Their side lengths are described by the p-theorem, the a squared plus b squared equals c squared. But they also form the basis of trigonometric ratios. Trig ratios. And the altitude that's drawn in this case here with this drawing, the altitude would be CD, drawn from the right angle to the hypotenuse, forms two additional right angles. So when we take this larger triangle, and we saw this in the last video, we drop an altitude, which means that we drop a line from the vertex perpendicular to the base of the triangle. We actually form two new right triangles, and consequently a relationship is set up between the sides of these triangles. So the larger triangle, two of its sides will be similar to the sides of the smaller triangles. So AC will be in this triangle, CB, you can see here, is in this triangle. And with these two triangles, we have the altitudes DC and DC. When the sides of the triangles are related, they produce proportions that have the denominator of one ratio in the numerator of another. So let's look at those triangles again. And I showed you that both of these have a segment, which is the altitude, which is DC. And if we call DC X, we can now set up a proportion where X is in the denominator of one of the ratios and in the numerator of the other. They call this the geometric mean. And in this case, in this set of proportions, X will be the geometric mean between M and N. Solving the proportion for X produces two equivalent equations. X squared will equal Mn, and X equals the square root of Mn. So this is just the process of solving algebraically. And let's take look at an example. If CD were 8, the 8 would replace the X in the proportions, and then we would have side lengths that were being compared from the two triangles. An example, possibly AC would be 16 and BC would be 4. So 16 over 8 equals 8 over 4. 8 times 8 using cross multiplication is 8 squared. 4 times 16 would be 64, but we're not even going to solve this. We're just going to show the relationship. We have 8 squared equals 4 times 16. If we just solve for 8, which would be X, we will have the square root of 4 times 16. So let's do an example of exactly that. Find the positive geometric mean between each pair of numbers. So we don't even need to look at triangles to do these problems as long as we have the values. So we have numbers of 3 and 27. We set up a proportion. The geometric mean will be X in between, and we can take our numbers 3 and 27 and input them. And we will have X squared equals 3 times 27. 3 times 27 is 81. If we solve for X, we'll take the square root of 81, and our answer will be 9. So the altitude of the right triangle will be 9. Let's look at B. We have numbers 6 and 9, and, sorry, this is incorrect. There we go. So we have 6 over X equals X over 9, and X squared would be 6 times 9. And without going through the step, that would be x squared equals 54, or x equals 54, and we would take the square root of 54, and the square root of 54 is 3 square root of 6. There's a corollary. In fact, there are two corollaries to this theorem. We'll have corollary 11.31a, and because there are different proportions that happen when we drop this altitude, we can also do comparisons not just with the altitude. We can do comparisons with different parts of the triangle. So I've actually added the piece of the triangles into this theorem, and the altitude, which would be CD, to the hypotenuse of a right triangle divides the hypotenuse into two segments. So this altitude CD dropped to the hypotenuse divides the hypotenuse into two segments. The segments in this problem are A and D, or you could also rename them X and Y. When this is done, the length of the altitude becomes the geometric mean. So they've marked this length h for height. So altitude is actually height. And they set that in the proportions. So instead of seeing x's here, you will now see h's here. And they've set the geometric mean between the lengths of the two segments. So we have the two segments x and y, and x over h equals h over y. What I would do with your theorems and your corollaries is to make sure you have the picture like this right next to them. And then our second corollary, we're still using the altitude, which is CD or h, to the hypotenuse, and it divides the hypotenuse into two segments, which in the last example we had as AD and DB, but they're also called X and Y, such that the length of each leg. So now we're going to compare a different piece of the triangle. The length of the leg, of each leg, is the geometric mean. So now we're going to take AC, which is the long leg of the large triangle, and we're going to compare it to this triangle ADC. We actually use B as the geometric mean, and we're going to compare B in this triangle to X, B in one triangle to X, and in the other triangle we're going to compare B to the whole length XY. So let me say this. What we're doing, imagine the three triangles drawn out. The larger triangle will have a hypotenuse that is much larger than the other two triangles. The triangles will each be pieces of the hypotenuse of the larger triangle. So in this instance, you're comparing one leg, B, making it the geometric mean, and then you're comparing these pieces. And for this triangle, it will be X to this. For the medium triangle, it'll be X. For the larger triangle, it'll be XY. Now you can also use a different leg, and you can compare leg A, and remember it looks like the hypotenuse on the smaller triangle, but it's actually the leg of the larger triangle. And I know this is confusing, but you should have drawings made so that you can see this. So you'll use A as a geometric mean, and you'll compare then the smaller portion Y to the whole portion XY. So take each one of these pictures with the corollary and write this in there with the picture. And when they ask you to solve for the geometric mean between each triangle, they're going to tell you solve for legs, or they're going to tell you to solve for altitudes, or they'll tell you to solve for the hypotenuse. And you'll be able to look at these proportions and say, well, which ones compare to each other? And this will take a little bit of practice. So contact me if you have trouble with it, because I want to help you get it straight. Now your homework, here's an example of one of the problems. It just says find the geometric mean between each pair of numbers. So you're not concerned with what parts of the triangles they are. You just have the geometric mean of x. They had numbers 1/2 and 1/8. So x times x is x squared. 1/2 times 1/8 is 1/16. And to solve for x, you have to take the square root of 1/16, and that will be 1/4. Most of your problems will be like this, or you'll be filling in a missing side that's a comparison. And I don't think you'll have too much difficulty. So your homework for part A is just numbers 1 through 7. Contact me if you have difficulty, and we'll walk through them together.